Now we're ready to build a more complicated project that more closely reflects a software as a service payment system in the real world. I've chosen Next.js along with Supabase for my tech stack, but I'd encourage you to try to build this project with your own preferred tech stack. So if you want to go with Svelte and Firebase or Solid and Pocketbase, you should definitely try to do that because the underlying Stripe concepts are very similar. Before we set up the project, I first want to give you a tour of what this app actually does. Basically, it's like a stock photography website where you can sign up for a monthly subscription and then download a set number of photos. You get a few photos for free, and then for any photos you download beyond that, you're charged based on your usage. If you want to run the full project, check out the README for instructions on how to do that locally step by step. When you run it, you should get a homepage that looks like this with a Buy Now button. However, if you click that button, a toast will come up telling you to log in. If you click on the User Auth tab, you'll see another button to sign up with a random email and password. After clicking the button, you'll see that we're now signed in with a random email address, and it also gives us a Supabase user ID. On the back end, that user's actually been created in the Supabase database, and we now have a user session in the application. Now let's go to the Photos page and try to download an image. This will make a request to our backend, but it notices that we don't have a Stripe customer account or an active subscription, so it's not going to let us download an image. To solve that problem, we need to actually buy something. Now that we're logged in, if we go and click the Buy Now button, it'll take us to the Stripe checkout page. This time we have a product that's a little more complex because it's a usage-based subscription, and as you can see, the pricing varies based on your usage patterns. And now after submitting the payment, you'll notice if we go back to the user data, we have a Stripe customer record created in the database. This keeps track of things like the Stripe customer ID, as well as the user's total downloads and their subscription ID. Now, if we go back to the downloads page and try to download an image, it will download successfully, but in addition to that, it creates a record in our database for the download, and also a record in Stripe to keep track of the usage, so we know what to bill the user at the end of the month. Now, at some point in the future, the user will likely want to cancel their subscription, and when they click on this button, it will take them to the Stripe billing portal. From this portal, they can cancel their subscription, and when that happens, it sends a webhook to our backend, which in turn will update the database, as you can see here on the customer record, so we know that the user's subscription will cancel in the future. And that's pretty much all there is to it. As we go through the code in this project, it's important to remember that there's no one-size-fits-all solution, and you'll likely need to customize things based on your own requirements. My goal is to show you the entire process from end to end to give you a solid foundation to accomplish those customizations. Now it's time to build out the actual application. The first thing we'll do is go into the terminal and generate a new Next.js app with the create next app command. When we run this command, it'll take us through a series of questions, and in this demo, we'll go with the defaults on everything. That'll have us using TypeScript as well as Tailwind, and we'll use the new app directory as opposed to the source directory in older versions of Next. After it's finished, we can then open that project in our editor. Go ahead and open up the terminal and run npm run dev to serve the app locally. That should result in a homepage that looks like this, and it says get started by editing the app/page.tsx file. So let's go ahead and do that now. Inside that file, let's go ahead and delete all the boilerplate code, giving us a basic React component that looks like this. The goal of this course is not to be an in-depth Next.js tutorial, but if you're new to Next, the most important thing to know is that it uses file system-based routing. In this case, we have a page.tsx component that represents the UI for the root URL. If we wanted to create an about page, we would create an about directory and then put a page.tsx file in it. When the user navigates to that page, it would render a React server component for that page. There's of course a lot more to Next.js than that, but when it comes to a Stripe integration, that's all we need to know for now. Now, the next thing I want to do is add some optional libraries here to improve our styling. This project comes with Tailwind out of the box, so what I'm going to do is bring in a UI library called Daisy UI. If you're not familiar with it, it's a UI library built on top of Tailwind that makes it really easy to implement different UI elements like buttons, modals, forms, and so on. Throughout the course, I'm not going to go over the styles in detail, but if you want to copy them, they're in the full source code. And in fact, when I'm demoing the code, you'll notice that the code is folded, and that's thanks to a VS Code extension called Tailwind Fold. Now, to use these plugins, you'll need to go into the Tailwind config file and make sure they're imported and added to the plugins array. That takes care of styling. The next thing we'll do is set up the Stripe SDK. Now, Next.js is a framework that handles both front-end and back-end concerns. And that means in this project, we're going to install both the Stripe SDK as well as the Stripe.js JavaScript library. We'll use these packages in future videos, but it's important to understand that the Stripe package is only used on the back-end, while Stripe.js is only used on the front-end. In Next.js, when you have the main default component in a page, by default, that's a server component that only runs on the server. However, when you want to run client-side code, you add this use client directive to the top of a component, which means this type of component is only rendered on the front end. And that's where you would use the Stripe.js front-end library. We'll tackle that in a future video, but for now, we need to set up our environment variables in a .env.local file. This setup is identical to the previous project in this course, but there is one important difference. The Stripe publishable key is prefixed by this next public namespace. That tells Next.js to make that API key available in the front-end code. Everything else will be kept secret on the back end by default. That takes care of the initial setup in Next.js. In the next video, we'll add a database and user authentication with Supabase. And now it's time to bring in Supabase, which will give our application a database as well as a user authentication system so we can keep track of our user data. There's a free tier, so this is not something you need to pay for. And again, if you don't want to use Supabase, I would encourage you to use your own backend, because for the most part, we'll just use it to read and write values from a database. After the project is created, it will take you to the setup page that will show you how to configure it in your preferred framework. In this case, we're using Next.js with the app router, but I'm actually not going to follow these instructions exactly. These instructions will provide cookie-based authentication, which is a good idea if you're building a serious application, but I'm going to go with the more simplified approach, which works fine as well, and will make it easier to teach the core concepts. We'll first want to go into the .env file and add the API keys for Supabase. We have an anon key and a Supabase URL, which are public variables that we want to use in the front-end code. So they're prefixed by that next public namespace. However, we'll also want to use the Supabase secret key specifically for our webhooks, and that should only be used on the back end, so we'll add that as an environment variable as well. Now that that's done, we need to connect those environment variables to our code. That requires the Supabase JavaScript SDK, so let's go ahead and install that with npm now. In the utilities directory here, I have two files, one for Supabase client and one for Supabase server. The client will only be used in browser code, while the server will only be used in backend code. In the client file, we import create client from Supabase, then export a variable that creates the client using the public variables that we set up just a second ago. Pretty simple, and now we can use that anywhere to interact with the Supabase database. Now, if we go over to the server file, you'll notice the code is identical, except for one small change. Instead of using the public Supabase anon key, we're using the secret key. And by doing that, it allows us full access to the database to write to tables that might be protected on the front end, which we'll need at some point when implementing webhooks, because in that case, there's no authentication cookie available to read. That takes care of the initial setup in the code. Now let's go to Supabase to configure a few details over there. If we go to the authentication tab and then to providers, the only authentication provider we have enabled is email. In this demo, we're just creating random mock users, so we're going to turn the confirm email option off. But of course, in your own application, you'll likely want to keep that on before you ship anything to production. The most important part though is setting up the database schema. Below this video, you'll find some SQL code that you can paste directly into the SQL editor on Supabase. That will create the tables that we use in this course. Supabase has a built-in schema for users, but we're going to extend that with two additional tables, one of which is downloads, which will keep track of each unique download that the user makes on the website, which we should be able to reconcile with the usage reports in Stripe billing. The other table is called Stripe customers, and that one keeps track of the user ID as well as the Stripe customer ID. It's also a convenient place to keep track of the total downloads and the user's current subscription status. We're not going to talk much about Supabase security in this course, but one cool thing you can do is enable row-level security to add rules that ensure that only the logged-in user who owns this data can actually edit it. That's critical before you go to production, but for right now, as we're just prototyping, it's not something we need to really worry about. Now that we have Supabase set up, let's put it to use in the next video by implementing user authentication. And now we're ready to implement user authentication. In this demo, I'm going to keep user auth as simple as possible, just so we have a very simple mock user to prototype with. Let's start by creating a page.tsx file in the user directory. This will create a new route that we can access by going to localhost 3000/user. Now remember, in Next.js, we use server components by default for pages. However, in order to log in with Supabase, we need to run some client-side code. To handle that, we'll create a separate component called login form, and the important thing to notice is that it has use client up here at the top, which means it will not run on the server. That allows us to import things like use state from React, as well as Supabase from the Supabase client utility that we created in the previous video. In the component, let's go ahead and create a loading state for when the user is signing in, then define a function that handles this process. The loading state will be initially set to true. Then we can use some JavaScript to create a random email address that ends at example.com. Then the password can just be some random characters. Now we're able to log the user in with a single call to the Supabase auth.signup method, which takes the email and password as arguments. That's either going to return some data or an error, and if it's an error, we'll go ahead and console log it just to see what's going on. Otherwise, we'll console log the data so we can check that out. Now, behind the scenes, when the user logs in, it creates a JSON web token that tells Supabase the user is logged in on the front end. In a later video, we'll decode that JSON web token on the back end to also authenticate on the server. But to finish this component up, we'll set the loading state to false after that process is complete, then come down here to the JSX and create a button that will trigger this function when it's clicked. And as an added touch, we can render some conditional UI based on the loading state. Now let's go back into our server rendered page component and import this login form and declare it there so we can see it in the page. Now if you open it in the browser, you should see this button, and when clicked, it looks like nothing happens. But actually on the back end, if you go into Supabase to the auth user schema, you should see a new record created there. In addition, that user is authenticated on the front end, and we'll learn how to take advantage of that data in the next video. Now that we have a login form that can get a user authenticated with Supabase, the next step is to fetch data from the Stripe customers table in the database. In a normal application, you wouldn't just render the Stripe customer data as a JSON object like I'm doing here, but for this application, it's useful for inspecting the data that we have in the database. To handle that, I'm going to create another component called user profile. This will also be a client component and includes a variety of imports here up at the top. We have two different pieces of data to fetch. One is the actual user, and the other is the Stripe customer in the database. What we want to do is write some data fetching logic that gets this data when the component is first mounted. We'll bring in the useEffect hook to run this code once when the component is first mounted, inside of which we define an async function that will first get the current user from Supabase. Now once we have the user and the user ID, we can then make a query to the Supabase database by fetching data from the Stripe customers table. We'll select all the columns on that data, then find the row where the user ID equals the currently logged in user ID, and then we'll use single to grab one record, and in this case there can only be one record because the user IDs are unique. If no data is found, Supabase will throw an error, but otherwise we'll set the Stripe customer on this component, allowing us to then use the data in the UI. That takes care of the data fetching process, but the other thing we have to consider is that the user might sign out at some point in the future. We can listen to auth events in Supabase with the onAuth state change function. It takes a callback function that will run some code whenever an auth state change takes place. Like if the user is signed in, then we'll want to set the user to the current session user. But if the user signs out, then we'll want to get rid of this data by setting the state to null. Now the onAuth state change function returns a real-time listener, so we'll want to dispose of that when this component is destroyed. We can do that by returning this function from the useEffect hook that calls the unsubscribe function. Now before we go any further, I do want to point out that there are different ways to manage authentication state in an application like this. The way we're using works for a single component, but it wouldn't scale very well if we wanted to do this over and over again in many components. It's nice to have all the logic right here in this one component, but just keep in mind that there are more efficient ways to handle auth when you need that state everywhere in the application. Now that we have that done, let's go ahead and implement a function to sign out, which can be accomplished with a single line of code. And now we can move into the UI. In the UI, we'll create some conditional logic that checks if a user signed in, and if they are signed in, we'll display things like the email and Supabase ID. In addition, we can add a button to sign out here. If they're not logged in, we can display the login form we created in the previous video. We can also add some conditional logic for the Stripe customer. If the data is there, we'll display it. Otherwise, we'll just render a message telling the user to go buy something to create that initial Stripe account. And now that takes care of the code and the customer profile component. Let's go back into the main server rendered page component, and we'll replace the login form with the user profile, then check out the result in the browser. You should have something like this, where after the user signs in, it then renders their Stripe customer data from Supabase. But currently, we don't have any data created yet, because that data doesn't get created until the user signs up for a plan and pays for something. We'll get to that in an upcoming video, but first I want to clean up a few things here in the front-end UI. In this video, we're going to take a minute to clean up the UI. When dealing with Stripe, we're making a lot of requests back and forth to the server, and one thing that can be useful is to have a toaster that will show a little pop-up notification whenever something goes right or wrong. To handle that, let's install a library called React Hot Toast. This will allow us to easily trigger these notifications from anywhere in our code. Once installed, we'll want to go into the root layout page and declare the toaster component there. We'll use this tool throughout the rest of the course, but you can see from the documentation, all you have to do is use one line of code, like toast success or toast fail, to render a basic notification in your app. That takes care of that, but let's also add a navigation bar to the app so we don't have to manually navigate to the URLs. I'm going to go ahead and define that navigation bar right here in the layout file. There's really nothing exciting going on here. We just have some UI which is styled with Daisy UI, and then a few links for the different pages in the application. Then finally, we can just add the nav bar right above the main content of the page. And now if you open the demo, you should have a UI that looks more like this, where we can navigate between the various pages that we're going to build in the upcoming videos. In the next video, we'll build out the checkout button, allowing the user to subscribe to a metered billing plan. At this point, we need a product and an associated price ID. In order to do that, we need to go to the Stripe dashboard and create a new product. In this application, we're selling a product that's downloadable, but the user is billed based on their usage for the month. The cool thing about Stripe is that it provides a ton of ways to customize payment plans like this. I'm going to go with one of the more complex type of payment plans you can create in Stripe. It's a recurring plan, but if you click on more options here, it gives you the option to switch from a flat rate to a usage-based plan. Now, with a usage plan, you could just bill $1 for every single unit, but in many software as a service products, they have tiered pricing. Like for example, in this case, we'll give away 5 downloads for $25 at just a flat rate. So that means we'll get a minimum of $25 per month no matter what. But if the user goes over that initial 5 downloads, then we'll charge $4 per extra download when they exceed the normal tier. And we can design all of that right here in the UI without having to write any code. I'd recommend taking a few minutes to play around with the settings and see everything that Stripe offers. But for now, let's just go ahead and create this plan to get a pricing ID. Now that we have our product created, we need to create a backend endpoint or API route in Next.js that creates a checkout session with the price ID. To handle that, I'm going to create a route in Next.js. This route will live in the API directory under checkout, and most importantly, it uses a route.ts file, which tells Next.js to render a URL that doesn't return a React server component, but typically just JSON or text. Works just like an API endpoint in Express.js or Hono, like we did in the previous demo. Now, before we implement the code, we're going to need the Stripe SDK. We're going to use the Stripe SDK in multiple files, so I'm going to create a utility file for it now. This utility file simply instantiates the SDK and exports it, so we don't have to keep rewriting this code for every endpoint. Now that that's done, we can define our endpoint by exporting a function named post. This function will run whenever a post request comes to this URL. Let's wrap this code in a try-catch block, because if it fails, we want to send an error response back to the client, which we can do with the next response helper. Now, when creating the Stripe checkout session, we have a few pieces of data that can come in from the client, like the price ID, email, and user ID. Those will come in from the body, which we can access with request JSON. Then we can use the Stripe SDK to create a checkout session. In a Stripe checkout session, you can add your own custom metadata, and that metadata is really useful, especially when you want to handle and fulfill an order with webhooks. Like in this case, we can access the user ID to then update the user's account. In addition, we also want to set the customer email, because if it's a returning user, it will tie that email to the existing Stripe customer in the Stripe dashboard. In addition, when creating a new customer, we want their Supabase email address to be the same as their Stripe email address. Now from there, we can add the line items for the products, In this case, I have our main subscription, but I'm also adding a one-time setup fee just to really gouge the customer for as much money as possible. Next, we'll set the mode to subscription, and then add URLs for success and cancel depending on the outcome of the checkout session. That's pretty much it. The only thing we need to return from this endpoint is the session ID, which we can then use in the front end to redirect the user to that checkout session. At this point, now would be a good time to go into Thunder Client and make a request to this endpoint just to verify that it's working properly. But that's optional because in the next step, we're going to make a request to this endpoint from our front end code. At this point, we have the backend endpoint in place to create the checkout session, but now we need to call that from the front-end UI somehow. To handle that, we'll create a new React client component right here in the root of the app directory called checkout button. The checkout button imports a special function from Stripe.js called loadStripe. Inside the component, we'll go ahead and write a function called handleCheckout, which will call our backend endpoint. But before we make a call to the API, we want to first make sure that we have a Supabase user, and if we don't have a user logged in, then we'll go ahead and redirect them to the login page or show an error message. That part's actually optional. You don't necessarily need to have a user logged in, but in our case, we're going to make it a requirement. And it also gives us a good opportunity to use that hot toast library that we installed in the previous video. If the user's not logged in, it will show a toast error message. Once we have the user, we can then load the Stripe SDK using that loadStripe function and our Stripe publishable key. After Stripe is loaded, we can then make a call to the API checkout route that we defined in the last video, and we'll pass in the price ID as well as the user ID and the user email. That's going to respond with the Stripe checkout session ID. Then we can use the Stripe SDK to redirect to checkout with that ID. The session also contains a URL, so you could manually redirect the user to that URL, but it's almost always better to let the Stripe SDK handle that stuff for you. Then from there, the only thing left to do is create the UI, which is just a button that calls this handle checkout function. Let's go ahead and add this component to our homepage, then pull it up in the browser and try it out. When you click on the button, it should take a second and then redirect you to the Stripe checkout page. You'll notice that Stripe gives you a breakdown of the tiered pricing, and it's also worth noting that you can customize the appearance with logos and colors, etc., which is all accomplished from the Stripe dashboard. Now remember, after the user submits the payment, it's going to redirect either to the success or fail route in Next.js, so you'll want to also create components to handle those routes. But more importantly, we also need to implement a webhook to fulfill the user's actual purchase, and that's what we'll tackle in the next video. At this point in our application, we can accept a user's payment, but now we need to actually fulfill their purchase when that payment goes through. And the way we do that is by listening to webhooks. To listen to webhooks, we'll need an endpoint on our back end. So once again, we'll create an API route in Next.js by creating a route.ts file at the API/webhook directory. The code we'll implement in this file is very similar to what we implemented for webhooks in the previous project. It starts out as a post route, and then we create some logic here to validate that the actual webhook is coming from Stripe and not some hacker from the outside world. And again, it does that by taking the raw body from the request, the Stripe signature from the header, and combines that with the webhook secret to validate the signature on the request, which means we know the request came from Stripe. If that signature request fails, we'll send an error response, which will stop the execution of the code. But assuming the request is validated, the next step is to run our actual business logic to fulfill the user's purchase. The event we want to listen to is the Stripe checkout session completed event. You'll also notice that I'm importing the Stripe checkout session type just so we get IntelliSense on that object. In development, it can be helpful to console log the data just to inspect it in the terminal because there's a lot of information in that object. But the first piece of data we'll want is the user ID, which was saved as metadata when the checkout session was created. Now that we have that though, we can use Supabase, and notice I'm using the Supabase admin helper, which has full access to do anything in the database that it wants to. We'll use it to make a reference to the Stripe customers table, and then use the upsert method, which will either create a new record or update an existing record with some new data. We'll save the Stripe customer ID as well as the subscription ID, and then set the plan active value to true, And since it's a brand new plan, it doesn't have an expiration date. This is what I would consider the bare minimum amount of data that you would want to store here. But remember, it's entirely dependent on your own business logic. So if you have additional information you want to store here, feel free to customize your Stripe customers table and store that data accordingly. In addition, you may want to do other things here, like send a transactional email. Like on Fireship.io, we use SendGrid to automatically send an email in our Stripe webhook when a payment goes through. In the next video, we'll also handle subscription cancellations and updates, so let's go ahead and add conditionals for those possible events as well. The next step is to make sure that the Stripe CLI is running in the background and is forwarding events to this webhook route. You'll find the full command for that in the description below this video. And just one other note on webhooks, when you actually deploy your app to production, you'll need to register your webhook URL in the Stripe dashboard. It's not something we need to worry about right now, but just keep that in mind when you deploy your app. With the app running in one terminal and the Stripe CLI running in another terminal, let's go ahead and try to submit a payment with Stripe Checkout. After the payment is processed, you should be able to go back to the user profile page, and now you'll notice that our Stripe customer data is populated. We now have a paying customer that we can grant additional privileges to in the application. In addition, if we go to the Supabase dashboard, you'll be able to see the record for the Stripe customer there as well. And that same customer ID is available in the Stripe dashboard, along with information about the subscription, payments, and so on. Now, if your application only sells a one-time product, you're pretty much done at this point. But when it comes to subscriptions, you also need to give the user a way to manage their subscription, to do things like cancellations, upgrades, and see their invoices. In the next video, we'll give the user a way to access the Stripe customer portal and also update our webhook to handle those events. In this video, we'll use the Stripe billing portal to give the user a way to manage their recurring subscription. We could create another API route, but Next.js 14 has a cool new feature called Actions. I talk about Actions in detail in the full Next.js course, but basically it's a way to write server-side code, then execute it directly from your front-end code without having to set up an explicit API route. The benefit of doing this is that it results in code that is a bit more flexible and easy to use. First, we'll create a new TypeScript file called portal action, and at the top of that file, add the use server directive. Like our API routes, this code only runs on the server, so we're safe to import the Stripe SDK here. From there, we'll define a regular JavaScript function that takes a customer ID as its argument. And now, all we have to do is call Stripe billing portal sessions create, pass it the customer ID, as well as a URL that we want to return to when the user is done managing their account on the Stripe hosted page. Just like a checkout session, that's going to return an object with a bunch of data, but we're most interested in the session ID and URL. So we'll go ahead and return those values from the function. Now the question becomes, how do we call this action from our front-end code? Well, to do that, let's go ahead and create a client component called portal button. And notice how this component imports the create portal session function that we just defined. The component itself is very simple. It's just a button that will bring up the Stripe portal when clicked. We'll define a function to handle the click, but first we need to get access to the currently authenticated user, and then use Supabase to make a request to the Stripe customers table to grab that user's customer ID. Once we have the customer ID, we're then able to call that create portal session function we defined, which will make the API call to Stripe and return us with a URL that we can then redirect the user to. And you'll notice that our code is far more simplified than it is with an API route, because we don't need to use the browser fetch API and instead just call the function directly. The only thing left to do in this component is define the button UI and run this code when the button is clicked. If that takes care of the portal button, let's go ahead and put it to use in the user profile component. We'll find the part in the conditional logic where we have a Stripe customer record and render the button there because we know at that point that the user is subscribed to a plan or at least has a Stripe account. Let's go ahead and try it out in the browser. When the button is clicked, you should be redirected to a Stripe hosted page, just like checkout, but this time it has information about the existing subscription and gives the user the option to view their invoices or cancel their plan. If we go ahead and cancel the plan, that will update everything in Stripe, but our application knows nothing about it. And that means we need to make some updates in our webhook code. When it comes to subscriptions, there's at least two events that you'll definitely want to listen to: subscription updated and subscription deleted. When we click that cancellation button in the Stripe customer portal, it triggered a webhook for subscription updated. When the user cancels, their plan is actually still active until the cancellation date or the last day of the billing period. It's just like when you cancel Netflix, where you still have access till the end of your 30-day billing period. When that event happens, what we'll want to do is update the Stripe customer table for that user. Their plan will still be active, but we'll update the plan expires field to the Stripe cancel at date. And then we can use that data in the front-end UI to show the customer a message like your plan is going to expire in 10 days or whatever the date may be. And that's really all you need to do to handle the initial cancellation. But eventually that subscription will be deleted in Stripe, which means the user is no longer a valid paying customer, in which case you'll want to revoke access. When the time comes, Stripe will send a subscription deleted webhook event. When that happens, we'll basically do the same thing with Supabase, but this time we'll set the plan active field to false and set their subscription ID to null because it no longer exists. And that's how we take care of cancellations in Stripe. Now, once again, you can expand on this code with your own business logic, but this is basically the minimum amount of data that you'll want to use in your application. If you have a flat rate subscription, you're pretty much done at this point. However, in our case, we're also doing metered billing. In the next video, we'll learn how to record usage to adjust the billing rate each month based on what the user has done in the app. Now that we have a subscribed and paying user, we're going to implement some functionality into this application that does something relatively useful. We have a stock photography application where the user can download photos, and each time that happens, usage will be recorded in Stripe to update their monthly bill. I've created a new route called Photos, and inside that route there's a page that renders a handful of images, but what you'll notice here is that each image has a special download button. This download button takes an image as a prop or argument, and when clicked, that button will make sure that the user has authorization to download an image, and if so, it will make a record of that accordingly. Let's go ahead and implement a client-side component called download button. This component will make a call to our back end, but one thing that's really important is that we authenticate the user on both the front end and the back end. Now, currently with Supabase, we're only doing client-side authentication with JSON web tokens, and that means we need a way to access the current user on a back-end API route as well. Before we implement that code, I first want to point out that there's a Supabase SSR package that does cookie-based authentication, and I would highly recommend going that route if you're doing a lot of server-side authentication. But because this is the only server-side route that we need to be authenticated, I'm going to add an authorization header when making a fetch call to our backend. That header contains a token that we get from Supabase with the getSession method. When we get to the backend code, we'll be able to decode that token to access the current user. Now, the backend will respond with some data that we can then use to show in the front-end UI, or as I'm doing here, just show a toast message. And when it comes to the actual UI itself, once again, we just have a button here that runs the function when clicked. Most of the magic happens on the back end in this usage meter API route. It's a post route, and the first thing we'll do in that route is make sure that we have an authorization token on the request. If not, we can throw an error. With that token, we can then call Supabase admin auth get user with the token as an argument, which will decode the token and give us the current user's data. Now that we have an authenticated user, we then need to make a request to the Stripe customers table for that user to make sure that they have an active plan. If they don't have a Stripe customer record or active plan, they're not authorized to download an image, in which case we'll throw an error. But assuming they do have an active plan, the next step is to make a record of this usage. You'll likely want to make a record in Supabase, which I'm doing here in the downloads table, to record the image that was downloaded. It's not totally necessary, but it's a very good idea just so you can reconcile it with whatever's recorded in Stripe. I'm also updating the Stripe customer record with their total lifetime downloads, which is also optional. And then finally, we record that record in Stripe. What's a little confusing though is that you don't record it directly on the subscription, but rather on a subscription item ID, because a subscription can have multiple items on it. Although in this example, we just have one item. If you have multiple subscription item IDs, you'll likely want to record them individually in Supabase just to make things easier to manage. But in this case, since we only have one, we can just grab the first item ID on that subscription. Now we can call the create usage record method with the subscription item ID, as well as the quantity that we want to increment it by. In this case, if the current usage was set to 11, it'll now be 12 after we record this usage. In addition, if you have a specific value that you want to set here, you don't have to use the increment action and can instead change that to set, which will reset it to a specific value. Also, it's a good idea and best practice to add an item potency key here, which identifies each request you make to this API endpoint. We can easily create that unique identifier with the built-in crypto module in Node.js. This will guarantee that Stripe only processes the request once, because occasionally network issues in distributed systems may attempt to process the same task twice. Let's go ahead and return a response from the endpoint and now try it out in the browser. If we log in as a new user and then go try and download a photo, you'll notice that it gives us an error saying that we need to subscribe to a plan. Let's go ahead and upgrade via Stripe checkout and now go back to the photos page and try it again. This time we get a green light saying that the image was downloaded successfully. Pretty cool, but now let's check out the user in the Stripe dashboard. If you go to the subscription, you'll be able to see the usage records there. Let's go back into the UI and smash the download button a bunch of times. If we now go ahead and refresh the Stripe dashboard, you'll notice that the billing amount has increased because we went beyond the base tier and now we're paying $4 every time we click this button. Congratulations, you just built a pay-as-you-go subscription product. I also want to take a minute to point out that there's many different ways you can record metered usage. It doesn't have to be based on some kind of interaction in the front end, and it often happens in entirely automated ways on the back end. Like maybe you have a cron job that runs once a day to aggregate usage for that period, then record it with Stripe. The API is extremely flexible, and you can also do things like implement billing thresholds, so if the user racks up a massive bill, you can charge right away instead of waiting until the end of the period. But at this point, we now have a solid foundation for handling payments with Stripe. Every implementation is a little bit different, but the core concepts I showed you throughout this course are present in virtually all of them. If you have any issues or problems, make sure to reach out on Discord. Thank you very much for enrolling in this course and supporting the channel, and I will see you in the next one.